So welcome to Spring Working Group. We have a full agenda, so we'll start on time. Thank you for being with us for the last slot. This is the IETF Notewell. It's a reminder for rules, including about conduct, IPR, and process. You should read the document because you already acknowledge them and confirm that you will comply with them. If you have any question, you can ask chairs or Eddie about those documents. This is IETF meeting tips. In short, if you are in the room, you should connect to the Meet Echo tool to be able to join the queue and record the blue sheet. And if you are remote, please mute your audio if you don't want to speak. The minutes are collaborative, meaning you can help to write the minutes and you can correct your statements on them. This is the link. So in terms of document status, we approved two documents which are currently in the RSC editor queue. One is a circuit style segment routing policy. I'd like to thank Drew and the authors for the final polishing on the PCEP text. And second document is distribute SRv6 locator by DHCP. So congratulations. We submitted another document to ISG, currently in AD evaluation. It's about resource awareness for SR segments. And finally, we are doing a last call on SRv6 security consideration. We did receive the review for SEC IntOps on RTG-WG Directorate. We did the first last call for 2 weeks and then extended. We'd like to have more feedback on the document. So the plan is to have the authors update the document with the comments received so far, so from the working group and from the directorates. And then we'll issue another working group last code. It's an important document. It's a document which has been asked for ISG so that security, SRv6 security is correctly handled. And it's also an important document for network operators to ensure that their deployments are secure. This is an overview of our Spring Working Group documents as filled by authors. So thank you for the authors. I think we have 17. I guess the main point is coming from service programming, and the authors have asked to split the document into two, one for MPLS and one for SRv6. And we'll send an email on the list about that. And finally, this is our agenda. Yeah, sure.
As Bruno said, we're very happy that you're here today. It's the last session of the last day. It's not always that everyone stays here. I'm very happy to see a lot of faces that I know and a lot of new faces. I'm very happy that we have progressed many drafts. However, I am not happy at all with the participation that we've been getting from the working group lately. We have been working, as all of you know, on that security draft for the last year and a half, almost 2 years, and we received a total of two. I don't know how to say two in Chinese, but two. Out of the working group. So I am disappointed that there's not enough engagement in the working group. That is an important document. A lot of people participated in the discussions. We had at least 3 different interim meetings. And in the end, we had 2 responses. If we go back to the, not back, actually go to the next slide. Um, these are the documents that have been adopted. As you can see there, many of the authors provided an update on the document, but about half didn't. So what I'm trying to get across here is we need working group participation. This is not up to us, Joel, Bruno, and me, to figure out what to do with the working group. This is about the working group reaching consensus and agreeing on things and having discussion. And to do that, we need traffic on the list. We need people to say they like things, to say why they don't like things, to make comments, to not rely just on the presentations that are made at the meeting. Some of these documents are very important. Well, I'm going to say all the documents are important, but some of them have external dependencies from other working groups, for example, the Yang models. And not only did we get an update, but we haven't seen movement on some of these drafts for years sometimes. So we need to see engagement. We need to see movement. We, as the chairs, can change the people working on the documents if we need the documents. If you don't want to work on the documents anymore, we can just, forget them. Or in the case of some of the important documents that have dependencies, we need to find other people who can do the work. And of course, finding other people is not enough. We need still everyone else to participate and to be engaged and to show as much interest as showing today in actually coming to the last meeting of the last day of a very long IETF week. So thank you for all the work that you've been doing. And I'm going to say thank you for all the work that you're going to do in the next few weeks and months and hopefully years of making comments and participating on the list. I know that all of you are not just looking at your email, but you're internally nodding and saying yes. So thank you.
So this is our agenda today. It's a full agenda. Any comment on the agenda before we move on to the first slot? So if not, the first draft about pass segment identifier for SRS6.
Okay. Hello. Okay. Hello, everyone. I'm Guanming Zhen from Huawei Technologies, and today my presentation topic is the path segment identifier in XRv6, the flag problem options analysis. Firstly, let's look at the backgrounds and objectives. The problem is the XRv6 lacks a unified path segment identifier comparable to SRMPLS PCID, which is illustrated in RFC 9545. And using a variable length segment list as a key in SRv6 is inefficient. So we need to define an efficient and unique 128-bit PCID, which is path segment identifier to support some different use cases, like the bidirectional path binding, end-to-end path protection, and etc. And currently, the protocol design in our job is like the following. First, the location is the PCID must reside at segment list n, where n equals the last entry of the segment list, which is depicted in this picture. And the structure, the PC structure follows the standard SRv6 seed format, which is locator, function, and argument. And the function has, and PC has its own function code. And now today, the main topic of my presentation is we want to discuss about the flag problem, how to efficiently signal to nodes that this specific entry is a path identifier and not a standard routing seed. Okay. Uh, and first, I want to thanks to Bruno's deep discussion with us, and we finally come up with 3 high-level approaches for community review. The option 1 is the dedicated P flag option, and option 2 is the generic G flag, and option 3 is the no flag mechanism. And now let's look at each option in detail. First, the option 1A is the dedicated P flag. The basic mechanism is we define a new bit in the SRH flag field, and we have a P flag in the SRH flag fields, like depicted in this picture. And the semantic is when P flag equals 1, it explicitly indicates that the segment list last entry carries a P seed. And this mechanism, the pros are it is simple and unambiguous. It has direct logic and easy to implement. But there are cons. The cons are uh, resource consumption because it consumes one of only 8 bits available as RH flag bits for a single function, which is mentioned by Bruno in the mailing list discussion. So we want to modify this mechanism. And also, with one P flag just for P seed, it has limited extensibility and it is specific to P seed and do not accommodate future metadata types. So, uh, and next we have option 1B, which is the P flag for generic data to solve the future extensibility problem to some extent. The mechanism is we still have a new bit in the SRH flag fields, which is P flag. And the semantics is when P equals 1, it explicitly indicates that the segment list last entry carries a 128-bit generic data. And PC is just one of the possible generic data here. And the pros are it has future extensibility and one flag just support multiple extensions and adjust the flag scarcity concern. And for the cons, it has uh, just like the option 1B, it consumes one of only 8 available SRH flag bits. Okay, and next we have option 2, the generic flag. Uh, Also, we need to define request a generic flag bit in the SRH flag fields. And the semantic is when G equals 1, it signals that the segment list last entry contains a 128-bit data with seed structure. And we use the opcode to define different use cases. For example, when the opcode is a 1, it means it is the parf segment ID PC'd. And if the opcode is O2, that means it may be some in-situ OAM trace data here. And for this mechanism, the pros are it has future extensibility because using one flag, it can support multiple extensions and addressing the flag scarcity concern. But there are cons. It also consumes of only one of a available SRH flag bits for a single function. And also, it is a bit more complex uh, than the option 1B because the C structure is needed to be defined. Okay. And next we will come to option 3 is the no new flag options. And here we have 3 sub options here. Option 3A is reducing the old flag. And since in the RFC 9259, we have already defined using the existing OEM flag. And we want in this mechanism, we want to just reduce that flag and to signal the PC presence. However, although we don't, the mechanism don't need to consume any SRH flags, but it has cons because O flag implies low parf sample OEM treatment, but PC often requires fast path and per packet handling of accurate end-to-end matrix. And such kind of mismatch in processing model risks other serving key use cases. Okay, and then we have option 3B. It is also a flagless mechanism, and it relies on the POC convention, and the mechanism is that the SR endpoint knows it do not need to read the flag field, and it just inspect the segment list last entry by convention without defining a flag. The pros are there are no SRH flags consumption, but there are cons because firstly, without a flag, the SR nodes on the parse need to read the 128-bit PC'd, which introduce more complexity than just reading one flag. And also, some potential risk is if without a flag indicating legal data at segment list last entry, the packet may be treated as illegal and discarded by some strict implementation. Okay. And finally, let's go to the last option, option 3C. It is also a flagless uh, option with dedicated PC prefix. The mechanism is it the SR endpoint nodes inspect segment list last entry and recognize PC uh, by prefix match. And here, the PC just have a different structure like this picture. And for the prefix, it is a reserved, well-known, non-routable IPv6 prefix, and the rest of the PC is the payload. And the pros for this mechanism is there's no SRH flag consumption, but there are cons. The cons is basically the same with option 3B, which is one is without flag, the SR nodes on the path need to read the 128-bit PC'd, which introduce more complexity than just reading a flag. And the second is without a flag indicating legal data on segment list last entry, the packet may be treated as illegal and discarded. And also, there are other cons like uh, with the with such kind of structure PC, then extra mechanism is needed to ensure the PC are unique across domains because of not using the egress nodes locator. And also, the extra mechanism is needed to inform which SR endpoint node triggers corresponding operation. Okay. Now, finally, we will come to this comparable analysis matrix. And totally, we have 6 options. And now we will compare them in different dimensions. First is the flag consumption. Option 1A, 1B, and 2, they consume 1 bit of flags, while other options do not use any flag. And then the next dimension is the processing model. Option 3A operates on the slow path, while other options operates on the fast path. So they are different. And for extensibility, uh, option 1A, uh, 3A, 3B, and 3C have low extensibility. And for option 1A, it has high extensibility because the P flag supports generic data, and the data is not is can be self-defined. And for option 2, the G flag supports some data apart from P seed, but the data should be in the seed format. So the extensibility is 1B has high extensibility, and option 2 has medium extensibility. And also the processing cost, let's focus on the option 3B and 3C. For, for these two mechanisms, they have high processing costs because they need to read the 128-bit seed instead of a single flag. So there may be higher processing costs for option 3B and 3C. Okay. And finally, and it is from the author's perspective, we believe option 1A is a simple and unambiguous way to implement to realize this function. And option 1B and option 2, they offers the best long-term balance. It conserves scarce flag space and supports future extensions. and maintains performance. So this is our author's recommendation. And finally, we want to kindly ask the work group to share your views on which direction best meets operational and architectural needs. And we want your feedback, and we will update the draft accordingly. Thank you.
Thank you for the analysis, Greg.
So I have a question. Why you think that in SRv6 you need the PCID? Because in SR and POS, as labels being disposed, so yes, their egress would not know on which of the path from ingress to egress their packet traveled. But in the SR and POS, SRv6, so all their unique SIDs are in SRH. So why do you need PSID in the SRv6?
Can I answer the question? Chang-Li from Huawei as an order.
Chang-Li is the first author of this draft. Yes.
Because Greg, Chang-Li, because if you use the reduced mode, definitely you cannot have the entire seed list. If you use the micro seed container, you definitely cannot use the cannot find the entire second list. So you can read the introduction section of this document. You can find more information. Yep. Thank you.
Okay, so then my second question is that why do you need to put it in the segment list and not to use the TOV? Because if you are using compressed SIDs, microSID or GSID, okay, so you're definitely concerned about the space, and putting PSID and 128 bits long, that seems to be a waste. So if you need it to be analyzed only by the egress, why not put it as a TOV?
Actually, no, let me.
I can answer the question. Like in the beginning, we did consider to use the TLV, but think about the TLV. How many TLV we are using now? Maybe only one, like HMAC. Do you want to use the second TLV? No, because it's cost.
Why not? No,
costs a lot
again,
in performance.
It's not. As I see it, it's not analyzed here. So again, if you're using compressed SIDs, so you're definitely concerned about their length of their SID list. And you're proposing to use 128 bits for the PSID for some limited use cases.
That's the reason why we proposed the option 2, so that with the whole 128 bits can be used for multiple use cases instead of only per segment.
As I understand, in situ OEM has its own definition using IPv6 generic approach, not using SRH. So I think that that's misattributed.
Yes, as you can see that we propose it as a future use case, that if someone is interested in this use case, we can discuss. But right now, we only define the flag for PC or the whole 128 bits, so that we can have the space for future use case, maybe for more use case.
It appears that 128 bits for the PCID is excessive. Okay.
I think the question has been heard and we need to move on to the queue, please.
Yes.
Can you put back the
Got Safar, then Chen-Li, then Aijin.
Asian.
Yeah.
Asian,
Can I go?
It's not your turn yet.
Yeah.
No,
Okay.
he was just answering a question. So it's Safar, then Cheng back, and then you.
I just want to explain.
Thank you. So my question is that what is so special about this past segment said that is need a special treatment? Why can it not rely solely on the n dot PCID behavior code, which is like any other set that we have defined thus far? So uh, you have option 3B in front of you, and you said high processing core, but it's like cost for any SID processing. So I do not understand why we need a special flag or a special treatment for this SID.
Yeah. Yes, I think for the flag problem, I think compared to the option 3B, I think if you do not have a flag, if you do not have a flag, I think there will be some efficiency degrade in this 3B the mechanism, because the SR nodes on the part need to read 128-bit PC'd, which introduce more complexity than just reading one flag. So I think uh, introducing this bit of this flag is beneficial.
So you said that SR nodes on the path needs to read this. Why nodes on the path needs to read it? It is the last. It is only the tail or the last SID or the locator of the last SID in this policy that needs to read this. Why other nodes on the path needs to read this?
Yeah. Generally, as a other, like we do provide some text in the document. So Java, if you have free time, you can read the document to understand better. So the main reason is that SRv6 has its unique advantage over against SM peers, right? So when we add a P seed in the SIH, definitely because it is a SIH, so the intermediate nodes can read the text. By this way, we can provide a possibility to support multiple use cases now and the future. That is the advantage over or against the SM peers. So in the design section phase, we did consider multiple solutions such as the option 3 and option 2 or option 1, and in the end we designed the option 1 and might be the easy way, and we can provide some you know uh, extensibility for the future. And after discussion with Doof and Bruno and other participants, we think option B might be a better choice, so that we can use this document or this extensibility for not only PC and other use cases, to not waste a single flag. So that's the answer. But we can
But
continue
but
to the discussion offline. Yep. Thank you.
but the question is that why you even need a flag and why you have to do the processing on any of the transit node. And if you need to do something at the transit node, that would be you're running on an IPv6 fabric. So you use hop by hop header, or you use
Yes.
the core IPv6 fabric facility.
Yes.
You don't hijack a flag to tell there's something in the packet that you need, and you're dealing with classic nodes, non-classic. Like classic means IPv6 cable node only, SRv6 node. So anything, we never have any thing where a node in the transit whose locator is not matching need to read something. So it's all funky. It's all not correct. So
No.
you need to justify why this is, what is so special about this SID that you need this special operation or a special flag.
Well, it's not for the transit node, it's for the endpoint node to read the 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 the, the field. And we did have some discussion with the six-man chairs, Bob Hinden and other chairs long time ago. And the conclusion was we need to uh, get a consensus here and then come back to the six-man and in the working group last call to check again. Yep, that's the
Yeah, I
conclusion.
mean, I remember that, and that was an individual draft, not a working group
Yeah, yeah, long time
document.
ago. Yeah.
long time ago, and the same comments were there at that time as well. Uh, uh, I think you need to justify that, and why it cannot work on a locator. I receive my SID, it's just like any other SID. It matches my locator. It's my SID, it's my PSID. I process it based on the pseudocode, and I process the next SID, and that's it. So I still don't understand why even you have to keep a special location, or why can you not treat it as any other SID?
We can have more discussion offline because it's a long
Sure,
story.
sounds
Yeah.
good.
Thank you.
Sounds good. Thank you.
And I think I have expressed my
Okay.
comments. Thank you.
Yejun?
Can you back to the slide, the second slide?
Second.
Yeah.
This one.
Yeah, here. I just want to maybe my case. I want to respond to the comment from the Greg. Maybe you know here the list the possible scenario for this PC PC field. You know, there are binding and pass binding and end-to-end pass protection. This scenario need not only the not only action the data limit and egress point, the transit point node also need to action this PC. So maybe I think it is reasonable to put the value in the segment list, not in the TLA values.
Diane?
This is Jiayuan from China Telecom. Thanks for sharing the idea. From my perspective, option 2 seems better. This solutions avoids dedicating scarce SIH fly bit to a single function, and can also be reused for PCs and potential future extensions. I think it achieves a better balance between the processing efficiency and operational complexity. Yeah, that's just my opinions. Thank you.
So thank you for the discussion, very interesting. I would encourage to further discussion on the list, because we had not a lot of discussion on the list, and it would be good to close all the points with a discussion on the list. I do have a comment on slide 4. We're kind of discovering that there are 2 implementations. There is no implementation section in the draft, although I asked it in July. And it is an issue because there is no code point allocated. There is no INR allocation for the flag, and no early allocation for the flag, and no experimental code point for the flag. So that means that the 2 implementations are squatting on the flag, on the code point, which can create interrupt issues between vendors and in networks. So I'd like the working group in general to consider to not squat on code points and only implement and indicate code points in the draft if and only if it has been allocated by INR. Thank you.
Balas, you're up next.
Yes, thanks. Okay, my name is Balazs Varga, and on behalf of the co-authors, I will present the update where we are currently with the draft dealing with redundancy protection. The redundancy protection is a generalized protection mechanism, and it is targeted to achieve high reliability. in segment routing networks. The mechanism uses a packet level active-active forwarding, and the draft defines a new seed, a redundancy seed for that, and that is the seed which is pointing to the redundancy functionality of the node. What algorithms the node using as redundancy is out of scope in the document, so it is just providing the possibility to implement redundancy protection on the node. The R seed has also a related redundancy policy, and this redundancy policy contains all the configuration regarding the redundancy functionality. What is the service protection action you would like to do, a replication or elimination or any combinations of them on the local node, and how these actions should be executed on the packets belonging to a given flow that is using this protection service. In the draft, we have also placed an appendix for illustration. There is a quite complex scenario described in detail how this redundancy seed and the redundancy functionality can work. And this is practically one of the use cases that DetNet also intend to use. So it covers a wide range of use case scenarios and protection topologies. And there were discussions from beginning between DetNet and Sprint Workgroup how to use this redundancy protection, because in the DetNet Workgroup we have a pre-of functionality called packet replication elimination functionality, and that is intending to use this function as well. So the document is in a quite stable state. There was only a single editorial fine-tuning. Before we have made this fine-tuning, we have sent to the list the proposed changes in the document, and that has affected only the description of the upper layer header processing to make the text very similar to the RFC 8986 format. That was the only change that we have done on the document. So it does not affect any technical part. It is more an editorial change in the document. The document is fully in line with the terminology and the DetNet architecture that we are using. So we think as the author group that the technical content is quite stable, and we think that we would like to ask for a workgroup last call on this document. Thank you. Questions, comments?
Does anyone have any comments, questions? So this is one of those drafts that it is a working group document and that has been around for a while. There hasn't been a lot of traffic on the list. In fact, the document was expired for a while. Balash, as we had discussed before, we need to generate working group engagement on this, some interest, some comments, whatever. So we need to work on that before we can start a working group last call. In other words, we're going to put you on the list, but nothing's going to happen until we have working group engagement.
Okay, thank you for that comment. So in the DetNet work group, we are definitely using this stuff, but yeah, let's have some discussion on that.
Lilian?
Good afternoon, everyone. I will present this work on the SRv6 for interlayer network programming. Next slide. In operators network, we have multi-layer network. Usually the layer 3 using IP technology. We also have the other layer 2 and below technology, for example, optical technology in the network. SRv6 provides the ability for the network programming by encoding network instructions in the packet handler. So we want a unified way for the network programming across the different layers. So this work proposes a new SRv6 behavior for interlayer network programming. The new behavior is called AND-IL. It's defined for the interlayer programming across the IP and the layer 2 or layer 1 technology. For example, to instruct a network node to send a packet through a non-IP underlay links or connections to a remote node by using this seed. We think we have three characteristics by using the new behavior. The first is the easy provisioning. It doesn't require IP address or routing protocol for the underlay connection or underlay connection its interfaces. The second advantage is guaranteeing the performance since the packet can be directly steered to the underlay TDM or optical passes. This passes is using the dedicated resources, so it can provide more guaranteeing the performance for the traffic. The third characteristic is flexibility and scalability. We can use underlay connections to be set up between any two remote nodes without to infect the current layer 3 topology and the layer 3 IGP parse computation. After the draft adoption, we update the draft according to the comments and discussions. The first is to update to clarify how the package is encapsulated over the underlay connections. And the second is for the layer 2, the approach of obtaining the destination MAC address is clarified in the draft. And we also add some tests on the use of SRv6 flavors with the current new behavior. In order to verify this function in practice, we run a hackathon project at this meeting. In this meeting, we carry a topology we can see in this figure, and the multi-vendor topology. We use devices from 3 vendors from Huawei, ZTE, and FiberHome, and the links are connected. We use an NIL behavior to direct the traffic to the underlay MTN, the Metro Transport Network, and FCMTN channels. And for the traffic flow, we configure the bandwidth to 600 megabits with different packet sizes. And we also to configure some background flows over the flows. And we can see in the table that several traffic flows, they have different source and destination nodes. And we also capture the script from the controller, from different vendors' controllers, and it shows the seed list, and we use the NIL list, seed in this traffic. During the project, the results is where verify the feasibility of this function, since the traffic has been directly steered to the MTN channel, and we also test the transport performance for these channels, and we can see even with conjections by the background flows, there was no packet loss, and the latency and jitter remained almost unchanged. After the variation, next we will continue to improve the draft and welcome any comments and feedbacks for this work. And we also plan to work on the control plane protocol extensions for this interlayer programming in other related working groups. Thank you.
Any comments for this one? Thank you for letting us know about the hackathon experiment. It's good to see implementations going. Okay, thank you.
Thank you for letting me speak. Alvaro's talk at the beginning of this session was important for you to understand. There's a link between the BGP, between the definitions you do here and the drafts you want out in BGP. If you don't help with forming the concepts, the BGP mechanisms cannot adhere to them. So I have several drafts in BGP that have no firm link in Spring. And so also I can't really tell in many of the drafts where the link is. So I'm left with a problem that you don't want. I'm left with the problem that says I can't publish these drafts because I haven't done the cross-working group work. So help Alvaro, help me, help you get your drafts into an RFC and your work into the network. So to make it easier, because believe it or not, I have on the docket 30 drafts right now that in various forms that have been asked to do BGP, SRT, or BGP. And I need to find, in order to publish it with the ISG, I have to find where it fits a Spring construct. I have to find either an RFC or a working group or an ID draft that tells me what it is. I have to then go and look for a PC in case the PCE work has been used. And I have to look for CIDR ops. And I'm starting to attend these regularly. You will see me in the back scribbling notes. So to make it easier, because Alvaro, Bruno, I would like you to go fast in getting your additions to the network if there are implementations. So I tried to think, what can I do? How can I make it easier for you that has an idea, an implementation? So we're going to go to perhaps solution 1, which says we'll require in every IDR drafts a section which we'll call cross working group. Okay, and that'll have a link to the Spring document, a link to the PCE document, a link to the CIDR ops document if we can find it. And I'll continue to do the slower thing, which is I put reviews for BGP documents that specify SR or SR I say as BGP with prefix SID attribute. SRTE is BGP with the SR policy. And of course, you know, BGPLS. Okay, so this is a plea, help me help you. Why is that? Here's the problem. That all sounds like process, but how do we know? Did you want to interrupt now? Please go ahead.
Yes, just on the last slide. Can you go back once? This is Dhruv. Basically, you were saying CIDR ops, but do you mean CIDR ops or SRv6 ops? On the slide, it says SRv6 ops.
CIDR ops. Excuse me, I said CIDR and it's SRv6 ops.
Yeah, so but SRv6 ops is little different because that's like after the standardization is done, then you come to the operational and write something. I'm confused that I don't think so. We need to put this at the same level as Spring and PCE. SRv6 ops is mostly work done after we have standardized things.
It's the same, yes. And if I'm not saying it right, I'll say all sorts of things. But the purpose is always, what do we care about as an ITF, or what we should care about from the IDR viewpoint, is what operators need. What they need goes to the top of the queue, and other things fall behind. So if I hear in a CIDR ops presentation from an operator that they need something, I'm going to listen really hard, because if they need something, we should pay attention because they're trying to deploy this thing. Okay, so that's why if there's a link, if I listen in CIDR ops like I did earlier this week, and I listen and I hear, oh, this person needs this sort of tracking, well, that would make sense to make sure that we listen all the way back the chain, that we listen if that feature comes up in IDR, and we listen if that feature comes up here in Spring, because those features matter. You know, it helps them make their network work. That's a basic fundamental principle of interoperability and running code. You want to find where the need is and make sure you meet it. Good question. A+.
We have another question from Ketan.
Go ahead.
So actually not a question, but to answer.
Can you speak closer to the mic?
Yeah. Can you hear me okay now?
Not really.
No? Oh.
I'll have to look.
Okay. Okay, fine. I'll put it in the chat.
Okay. Folks, I've been working really hard. Every cycle I've reviewed all the SR, all the SRTE, and all the BGP drafts, whether they're working group drafts or for IDR, or whether they're just proposals, because I realize this is an important area and I've taken time to review all of them, and you'll find them on the list. So I'm doing solution 1 and solution 2. Solution 2 is me giving you the information. Solution 1 is you giving me the information about cross working group. Okay. This is about why I'm taking these steps. The problem is we have to do this check first to make sure we're doing the right thing for the operators. We have to know the BGP mechanism aligns with the concept. We have to know whether it's going to help or hurt the SRPM, and we have to follow it back to the people who are using it to get feedback, right? So these checks are all about, is it going to be used? Okay. How do I find all of this out? Well, I track the tunnel in caps, and I track all the things that are there. So before we've been adopting it, we've been trying to find, is it useful? We do the same thing for the BGP SR with the prefix. Okay, so right there in the yellow, and I tried to do this so you could just watch it, you see where those are already existing working group drafts that are about to go toward working group last call. I don't know if all of those features are useful. I don't know if the path MTU ID that's in the sub TLV is useful. It would be wise to ask those questions so that we could do a good job about following through. There's also the MPLS label. All the things in red are proposals. Okay, there's a lot of proposals. If they all are beneficial to some operator, I'm happy with that because it's information we're passing that's being used. But if it's not useful or it isn't well defined in Spring, then you're wasting your time if you're proposing it in IDR, because I'm going to have to go back as the IDR chair checking all of this, go to Spring. I'm going to have to go to SRv6 and listen to make sure it works well. Okay, here are some more. You can pull down this list in the slides, but you can see how you have many of these things that conflict. So here's some thoughts I'd like you to think about to help me help your individual drafts come out. Are all the identifiers helpful? You know, we have names, bindings, NRP, segment list ID, path segment ID information. Do they all make sense? Do they interoperate? How many of the metrics are useful? There's a whole list: weight, metric, BLI list, segment list, may have path segment and MTU. Are all of these necessary? How and why does color interact? There are 5 generations of color. There's TLV, sub-TLV, sub-sub-TLV. Then there's the extended community. Then there are LRIs with color. Is this all useful? It doesn't have to be useful in one place. It's just we're looking at the whole range of this and asking that question. And do any of the head-end actions interact or conflict? Now, they can all be there and they can all be wonderful. But I, as a engineer and standardizing all of this and spending the time, should ask you that question, and you should have an answer when I come to review your draft. Other drafts are much more complex. For example, I've talked to the segment list optimized people and said, do we have enough to make that decision at this time? Is this a good optimist? Might be. I'm not doing deployment. I've talked to the composite list people and said, do we have the right understanding of what composite list will do to BGP? And we had wonderful discussions this week about that. And I think it helped them and it helped me understand what they're coming from and where the limb. Okay. I've got a lot of people looking at me like they haven't thought of this, but the chairs actually and the reviewers actually do. So we will be putting a lot of these drafts through the SR, through the BGP during their working group process, and I want to make sure they have the tools to review your drafts and help you. The whole purpose behind IETF from the IDR viewpoint is that we get good specs out that help the operators do their jobs and make this technology a wild success. Questions?
Can you please say your name since you didn't get on the queue?
My name is Liu Yanghan from China Mobile, and thank you very much for give the information and as a participate from operator. I think I and my colleagues are very willing to give us give the IETF our some use cases and some requirements, and want to give the feedback of what technologies have been really deployed in our network. But I also want to give a, I'm not sure if it's a proper suggestion. If we can give the technologies that was really deployed in the network to give them some higher priority in the IETF work. Thank you.
Thank you. I must commend the operators in China and the operators working with RSR. You are some of the best responders I've seen. So thank you to you. And you keep making those comments and keep realizing if you need something, tell us again and again, and we will work hard. That's all I can say, but we promise to work hard to make sure you succeed. That's our goal. Did I miss a question?
Asian has a question.
Hi, Asian.
Yeah, just one suggestion. So is it the right time to select one expert from operator to help you guard this draft? You know, I have expressed several times that the final aim of the RFC should be in the network service provider network, but currently the output of this RFC can be controlled by or can be selected by the operator expert. This is a big issue, right?
Yes, and Agent's been very good about making lots of comments and staying in here and telling us what he needs. And we work hard to get there. It may take us time. Okay. So please listen to Alvaro and Bruno and Joel when they ask you to do the concepts, because right now we're stuck behind you doing what Alvaro asked. You're not going to get your BGP mechanisms out to you. Pay attention and I'm sorry, I sound like I'm a Me Too.
So as Sue just said, listen to us. So all of you, I know, have read the charter for Spring. Spring is chartered to define mechanisms to steer packets across the network. We're not chartered to change any protocol. So what that means is that the discussion on how things happen in the network happen here, the generic discussion. The specific implementation of where do you put the bit, or is it a TLV or a sub TLV or whatever, that happens somewhere else, in IDR, in LSR, in wherever. There's a lot of work that we do with 6-man as well. We have an active working relationship between the chairs with 6-man, with IDR, with other working groups like SRv6 Ops and LSR, where many times they come and ask us, is this something that Spring wants? And the only way we have to answer is if we look at our own documents and we see those procedures defined here. So some of the questions that Sue asked in her list, for example, all the colors in the different places, should they match? That is something that is not always clearly defined in the Spring documents. So us as chairs can't give them, the other working groups, an answer that the working group hasn't agreed on. So this takes me back to the beginning of the session. Please engage and participate and etc. Because even if there are documents that you came and talked about here, if there's no engagement from the working group, all we can say is, well, we don't know. The working group doesn't seem to care.
I started this because I have a list starting with segment list ID, which we got halfway through the call to and raised these questions that we want to go back to an IDR and go back to quickly. But if asking Spring takes a long time, it will take me a long time to get through all the adoptions. So anyway, this is a plea. Help me so I can help you.
Thanks, Sue. Please engage, review other people's drafts, review so that people review your drafts, etc. Right? This is a working group. So now we're in the part of the agenda, Feng, you're up. Now we're in the part of the agenda where we label this if time permits. So please try to stay to your time. And if we get through everything, that would be great. If not, then we'll have to do it next time. Thank you.
Hello, this is Feng Yang from China Mobile. The topic is SRv6 pass verification. The reason why we do this is because we are thinking that SRv6 not only matters the operator's network, but also matters the SRv6 utilization adoption in the enterprise scenarios. So as we know, that a lot of SRv6 security suggestion or issues considerations has been registered, has been put into the document. So here we come up a solution to want to address part of that issue, give a solution on that. So the brief history of this personal draft is from 122 meeting, and we have proposed one solution with a linear combination of the authentic code of different node, traversed node. So this we have a long time of discussion in the mailing list and improve that in the 123 meeting, and comes up with a recursive authentication. That's kind of algorithm. And in this and comments in that meeting is some people think that operators network is good enough, is not needed for this kind of solutions. So we think that is also matters for the enterprise deployment cases, because security boundary is not clear like what we have in the operators network. Although I'm from China Mobile. So the problem and solution recap. Look at this picture. The problem is that we cannot strictly check if the SRv6 forwarding the packet forwarded actually very just as what is it is in the follows the SID list in the packet. That is because today's solution that only authenticates the SR seed list in the SRH header. It doesn't put any information when the packet is forwarded across a network. So, for example, there is some malicious user just want to do some of the illegal VPN access. The expected traffic is from P1 to P1, P3, and to the PE2. The malicious user just inject the traffic from the P2 with the correct SRH, that is P1, P3, and PE2. We will not be able to identify that case. So the solution here is have information injected on every node. That is, we do authentication on on every node with, for example, the authentication code on P1 on the start of the SRv6 is empty, and on P1 the authentication will be done with two input. One is authentication coming from the P1 and the authentication against the DA, which is coming from the seed list. So with that information, that will be put into authentic code and go to next code, go to next node and do the same thing again along the path to the tail node. So on the tail, we can know if that path is strictly matches the path listed in the SRH seed list. So that's the solution. So the benefit, we think that is there are several benefits. That first one is of course we can check if the real forward path is just follow the seed list. And the second is we have constant authentication auth node in the packet, regardless of the seed list, length of seed list. And the third is, I think the computational complexity is constant, regardless of how many hops it will pass, because all of the work has been distributed in every node. So, and because of the computational complexity is constant, it will be hardware friendly. It can be implemented by the hardware easily. So that's a solution. We think that is important for promoting the SRv6 in the many domains, so many areas. So next step we would like to ask for the adoption if no objection. Any comments?
Yes, Quan, go ahead.
Zhuan Sheng from ZT, thank you for your presentation. I think it's a useful method to address the security concerns such as the modification attacks and the packet insertion attacks. But I have two suggestions for you for your consideration. First one is that you may need to make sure that the process and the algorithm is simple enough to be deployed across all the nodes to support the hop by hop verification. And the second one is that maybe you also need to consider the capability legalization and or the backward compatibility, because maybe some of the nodes do not support the verification method. So just two suggestions for your consideration. Thanks.
Yeah, thank you. I think that should be considered in this document.
Greg, before I go to you, this reminds me that we should be putting operational considerations in our drafts. So the operational consideration of the backwards compatibility is something that's going to be important. So not only for your draft, but every other draft that we've been going to be working on. Thanks, Sean. Greg.
Yes. Hi. So seems like what you are trying to solve is a proof of transit.
Yeah, Greg, we almost can't hear you.
Okay, is it better now? Okay, is it better now?
Slightly. It's being transcribed over there.
Okay, so it seems like you're trying to solve is a proof of transit. Have you looked at the work that's being done in SFC on IAM proof of transit?
So I think the question is that there's some work going on proof of transit. Did you look at that?
Yes.
Yeah, I'm not.
It's work that went on in the past. It's not going on right now, but it is historical work on this topic.
Yes, it's been done, but I would think that you can look at it and see if there is anything that will be reusable and applicable to your work. Thank you.
Yeah. So, do you have any? Maybe we can have some mail conversation. I'm not aware of that at this moment.
It's work that happened in the past in the SFC working group for NSH proof of transit. So go take a look at the SFC documents, and Greg or Joel, if you have a pointer, can you send it to the list? That would be great.
I put it in the chat.
Yep.
Thank you.
In the chat.
Thank you.
Anyone else? Okay. Thank you. So you're still on?
Yeah, next. So again, this is the second of the presentation. The topic is SID as source address in SRv6. Why we do this is because several years ago we are working on some enterprise solution. We found that SRv6 cannot pass through the firewall with illegal with legitimate SRv6 traffic that has been dropped. So the initial solution is to try to have another of encapsulation. That encapsulation is firewall friendly encapsulation like IPsec and L2TP like that. So finally, we find a solution in 3 years ago, and we have presented it in the IETF 116 in spring. We defined two mechanisms. One is how to make the SR6 compatible with the firewall, and another one is how to verify if there is some falsified destination VPN SID. In the meeting of 123, comments are mainly for the verify of the destination's SID. Destination VPN SID is more kind of theoretical. So in this version, we accept that comments and remove the how to verify the falsified VPN SID in the draft and keep only the words how to make the SRv6 compatible with the firewall. So recap of the problem. Let's think of their scenario of network in SRv6 network with a stateful firewall in between. The problem is today we have the SRv6 packet source address is a loopback address in one as a source address. So on the left, the source address would be the loopback address of P1. On the right side, its source address would be the loopback address of P2. So that's create the problem asymmetric of the symmetric address. So that cannot be friendly to the session table in the firewall, stateful firewall. So solution is to use seed as source address. So this has several benefits. One is will be zero overhead because we just replace the source address with the service seed. And another one is it would be hardware compatible. There is no need to do any hardware change. And third one would be it would simplify the solution without to have additional encapsulation of like IPsec or L2TP. So there are several changes. One change is we have specified when to use seed as source address. This comes this is mainly specified that only the unicast traffic should be use a seed as source address with all of the service seed except the multicast ones like NDX and NDT. The second update is we have people just even before just asking how to determine which SID, service ID, SID we need to use. So we have make some clarification on this because all of the service SID are allocated by the node itself. So it knows when the traffic coming the node. So it knows it's belong to which service. So it can determine which service SID it can use. So we have updated that. And update 3 is we just remove the how we just check if the destination VPN service SID is falsified or something like that. So so we would like to have the WJW call as informational, even no back objection. Any question?
So far, you're on the queue.
Yes. So you have in your slide SA equal to the VPN SID. What you need to consider is that if there's an ICMP error in the packet, and then the packet come back to the source, then this will be processed in the context of VPN SID, which will be incorrect.
Yeah, we have already considered the ICMP cases in the document.
Okay, so curious to find how you process it when the incoming packet DA is pointing to this, but it's fine. Thank you. We can talk offline.
So, yeah, if we are doing ICMP ping for the tunnel, we will not. I think I'm not sure. We have put some words on that document. We can check that in the document.
I'm not talking about ICMP ping or trace. I'm talking about if there's an ICMP error on the data packet that you're sending, and then you have to handle that. It comes with VPN SID, so it gets processed incorrectly at the ingress node.
Yeah. Thank you.
Hi, Yao from ZT. I think that it is a simple and workable solution. So I'm not a file expert, but I used to use it a little bit. So about setting the SRv6 service set as a source address, kind of related with the first comment. So another use case is it can be used for the ICMP error handling in SRv6 networks. And there's also individual draft. I think it's in 6-man, so presented this IETF. Also, it wants to set the source address as a VPN SID. So I think you may want to look at that. So yeah. But I think it's a valid point to work on. Yeah, that's all.
Yeah, thank you.
One question: is it specific to VPNs, or do you have a broader applicability?
Today, I think that's only applicable to the SRv6 services, like VPN services.
Have you presented it in base working group?
Not yet.
Well, I would like to suggest to either present or send an email to base working group, because SRv6 services has been defined in base.
Okay.
So we like to have their feedback.
Okay, thank you.
I'm yet to read the draft and better understand what you're trying to do, but if you are to work on it, please extend it to non-VPN use cases. There are actually some use cases that might be interesting.
Okay.
Make it generic, please.
Okay, thank you.
Thank you.
Thanks everyone's comments.
Gojen.
Okay. Good afternoon, everyone. I'm Guo from China Telecom. And my presentation is for map6 segments for IPv4 service delivery over IPv6 only underlay networks. And my draft is 5. Okay, the background of the working group framework about IPv6 only propose a framework for deploying IPv6 only as the underlay in multi-domain networks. In this framework, a address mapping rule is used by the ingress PE to generate IPv6 source at the next destination address from the IPv4 source at the destination address when its egress is a given PE and vice versa. And as shown in figures, it's a multi-domain underlay network. And for map6 segments is a new type of segment for segment routing. They run in PE nodes and provide support for implementing IPv4, IPv6 conversion function based on address mapping rules in multi-domain IPv6 only underlay network. In this draft, we defined a new seed. The seed consists of a locator function, arguments, and the address locator is encoded in the L most significant bits of the seed, followed by F bits of the function and bits of the argument. As shown in picture is the seed architecture. The locator field has the pointing function. It is unique in the SR domain, and the function field identifies the behavior bound to the map6 seed, and the argument field contains the behavior identity of vendor stateless or encapsulation or translation is performed at a point at the IPv4 address associated with the PE node. And in the section 3 of this draft, we define a new BGP prefix seed attribute extension TLV in the RV6 service. TLV is to implement seed signaling for the map6 service of the SR6 service. And TLV type used to identify different TLVs. It's about it's 8 bits, and the TLV length, the total length of the TLV is 60 bits. About the behavior in general, map6 nodes operate in pairs for a particular data stream. One node is the egress PE donated by PE1, and the other is the egress PE donated by PE2. Each PE maintains a mapping rule database, like in the structure of a map rule database as shown in figure. And the table entries in the MD database consists of V4 address prefix, IPv6 mapping prefix, and the encapsulation or translation processing way of IPv packets as shown in the figure. Before translating a IPv4 packet from P1 to P2, the address mapping rule corresponding its IPv4 destination address needs to be transferred from P2 to P1. And that's all my presentation, and thank you for your listening. Due to the time limit, I need to catch my flight at 5 o'clock, but I highly hope to receive more comments to update our draft. And thank you for your listening. We authors would like to request a working group adoption of the draft. And if you have any comments or questions, please email me. Thank you.
Thank you. Go, run. Any questions or comments or anything else, please send them to the list. Yeah, that's all I'm going to say right now. Everything else, we're going to go to the list. And we have one last presentation, Xiaoming.
Hello, everyone. I'm Xiaoming from ZTE. This presentation is on encapsulation of BFD for SRv6 policy. this is the introduction on this draft. As we all know, BFD mechanism can be used for failure detection of SR policy. And this draft describes the encapsulation method of BFD for SRv6 policy. For encapsulating the BFD packets for the SRv6 data plane, 2 modes of encoding are defined in this document. 2 modes are insert mode and encaps mode. This slide shows the format, encapsulation format for insert mode and encaps mode. For insert mode, an SH is inserted after IPv6 header of BFD packet. This mode reduces header overhead and reduce detection packet bandwidth. In this encoding mode, PSP is not supported. On the another mode is encaps mode. In this mode, an outer IPv6 header with an SIH is encapsulated. And this mode preserves the original complete BFD packet, only modify outer IPv6 header. For this encaps mode, both IPv6 and IPv4 BFD packet can be encapsulated.
Give me a second. Joel, do you have a question about the slide?
Yes, specifically on the first half of this slide. And when you talk about insert mode, is the BFD packet that you are inserting this into originated by the same node that is inserting the SRH, or are you claiming you are inserting an SRH into a BFD packet that you received?
You mean for the insert mode, is that the same node to encapsulate the BFD and the data packet? Is
the node which is producing the BFD packet and the node which is inserting the SRH packet, the SRH header, in your insert mode, are those the same node?
I think that should be the same node.
Okay, you need to make that explicit in your draft, because if it is not the same node, this is a violation of the IPv6 standards.
Oh. Okay, thank you very much. Thank you for your comments. Okay, this slide shows how to ensure BFD packets reach the tail end of the SRv6 policy. In this edge, the first element of the segment list contain the SRv6 seed or IPv6 address of the tail end node. So when the last seed in the SRv6 policy is does not belong to the tail end, then an additional tail end IPv6 address must be contained in the SIH to make sure that the BFD packet can reach the tail end. This slide shows special handling of the UDP checksum. On the left side is the insert mode. For insert mode, UDP checksum is calculated using the source address of IPv6 header and segment list 0 of the SH as the destination address. On the right side is the encaps mode. For encaps mode, the UDP checksum is calculated using the source and destination address of the inner IPv6 header. running code. Yes, we have already done the lab interrupt test for the BFD. Yeah, BFD is an important failure detection mechanism for SRv6 policy. We all know that. So in 2022, the interrupt test was hosted by China Mobile, and many vendors have already joined this test. This is a draft history. This document was presented several times, and there are some revisions to improve it. Yeah. So next steps, yeah. Maybe consider working group adoption. Thank you.
I'm sorry, NVIDIA, have you considered how it would work with USITs or compressed SITs?
Yes, we have already considered that CSID, USID, yes. I think, I'm not sure current draft has already covered all the cases, but we have discussed that. If any specific missing part in this draft, please send us comments on any of this.
I would think it would invalidate insert mode.
Insert mode?
Yeah.
Okay.
It validates 8200.
Yeah, understand. Thank you.
So far.
Yeah, I think, I mean, my only comment is that the way this is in cap insert mode are the obvious thing. Do we really need to document it? If we have to document, if we're working to find that, yeah, fine, it's better to document, then it's fine. But yeah, it would be done, these probe packet would be done this way. I think PM and all the other probing packets are crafted like this.
Your voice is a bit low. Do you mean that only one mode is needed, or?
No, I was not saying that. No. I was saying that, yeah, this method that you're doing is how anybody would do it. So do we need a document for that? But if you feel like we need a document for that, that's fine.
Yeah, I think the working group can discuss whether a document is needed for BFD encapsulation. And you know, this draft gives some recommendations on how to encapsulate the BFD for the SRv6 policy. We think maybe that's valuable and helpful, but we can discuss, right?
Have you found interrupt issues, or is it a local choice of the center?
No. Yeah.
No interrupt issue.
I think as far as I know, no.
Yeah, so Kevin put in the chat that maybe if this is how people already do it that maybe this is something that belongs in SRv6 ops. Drew is not paying attention to me, so I'm going to say that we are going to talk to the SRv6 ops chairs and figure out, as Safar said, if we're going to need a document, maybe it might be something operational already. So we'll figure it out.
Okay, thank you very much.
I'm impressed in how no one moved, because I said before that this was the last presentation and still no one moved. That makes me feel so good that you pay attention to the things that I say. If you heard anything, remember what Sue said, pay attention to us. Right? That's the most important part. So thank you for staying the last session on the last day. Thank you to the commitment of the person who stayed here until she almost missed her flight. And we hope to see as many of you as possible in the next IETF in Vienna. Thank you.
Thank you all.
No, I'm just going to Shanghai for 3 days.